Hi everyone, we're starting with a new lecture series, and this lecture series will be on Indian physical geography. Now, to understand the different geological features which are there on the Indian subcontinent, we need to understand the geological history of India, some basic geological history of India. And to understand the geological history of India, we need to understand certain important basic concepts related with the physical geography. Now, this part is not so very important for the UPSC per se. Not many questions have been asked. Some hardly 3 or 4 questions have been asked in last 20 years, if you see. So it doesn't become very important for examination per se, but it is important if we touch on the basic concepts, which will make the foundation for us to study further. So we will start with the physical geography, basic concepts. Then we will move to the geological history of India. Then with the Indian physical geography. And this is a very easy topic if you compare with other syllabus of the UPSC. This is a very easy topic, easy to understand. And there are two books which we need to follow for this. The first book is the NCRT. NCRT, particularly for the geography, it is very important. So, because nothing will go out of geography from the static part. Now, the second thing what we need to do for the UPSC is to look out for the new places, the new geographical reliefs, which comes in news. Okay, so geography is a vast subject. We cannot cover everything with the help of books or with the help of a course. So, we need to upgrade ourselves every time we find. New place or new river or new mountain or new pass in news. So that is how we will keep updating our information. And a good student always keep good atlas with them. So atlas is a very important thing to learn geography for the UPSC exam. And one more book, Geography Through Maps, is a good book to take the reference from if you have find any problem with related to maps and other things. So these four things you should be having with you. Gishing Long to understand the basic principles of the physical geography. No other book is required, Kullar and all. So second is the NCRT books. Then third is the atlas, and then fourth is the geography through maps. So these four books are very important for the geography section. Now we'll move to the agenda, the Earth structure and composition, why Earth has layers, how do we know about the Earth interior, and introduction late to the plate tectonics. Everything will lead to the plate tectonics, and we'll learn. It's a very simple topic. Okay, so let's move to the Earth structure. We all know we broadly divide Earth structure into three parts: the crust, the mantle, and the core. So these three are the basic three divisions of the Earth interior: the crust, the mantle, and the core. Now you can see on the figure you have crust, then you have lithosphere. So lithosphere is the crust plus the uppermost layer of the solid mantle. So we have crust, mantle, and core. So crust plus the uppermost part of the mantle we call as a lithosphere. So lithosphere is clear, crust, then crust plus uppermost part of the solid mantle we call as the lithosphere. Then we have a very important layer for the plate tectonics, that is asthenosphere. Okay, below lithosphere we have asthenosphere. Then we have mantle, we have the upper mantle and the inner mantle, which goes up to the depth of the 2900 kilometers, and these are always the approximate distances. Then below mantle we have outer core and the inner core. The very important thing which we need to understand is the outer core is liquid while the inner core is solid. Liquid, why? Because of high temperature. So high temperature will melt the metal. But why? Then because we remember three basic things: the pressure, the density, and the temperature will keep on increasing as we move inside the earth. Pressure, density, and temperature, these three things will increase as we go inside the earth. So temperature will be much higher in the inner core, but still the solid, it's solid rocks. It is made up of solid metal elements. So why it is? Because of very high pressure. Though temperature is very high, but pressure is very high, so that makes again the liquid solid. Okay, so this is the basic division of the Earth interior. Let us talk about the crust first, the uppermost part. If you remember this figure, uppermost part, it is made up of two types of different crust. First is the oceanic crust, which is ocean, simple, which is ocean. Then we have continental crust, which is also we know it is continent over which we have surface different landforms like mountains, the plateaus, the plains, hills, everything, right? So continental plate and oceanic plate. So two types of crust we have: oceanic crust and the continental crust. So continental crust over which we have continents, and oceanic crust over which we have oceans. Continental crust, it is also known as Sial. Sial is nothing but silicon and aluminium. It is made up of granitic and andesitic rocks, and dominant mineral is feldspar. Density, the very important thing to remember about the continental crust is its density, which is 2.6 gram per centimeter cube. If you see the density of the oceanic crust, that is 3 gram per centimeter cube. So the first point which we need to remember is oceanic crust are more denser. A very important point to remember, because that is how actually whole plate tectonics move. Okay, the whole plate tectonics concept start because oceanic crusts are more denser than continental crust. So note it down. The thickness is 40 kilometers, so a thick crust. If we come to the continental crust, it is known as SEMA. SEMA again nothing but silicon and magnesium, made up of basaltic rocks, and dominant mineral is ferromagnesia. Density we have seen 3 gram per centimeter cube, and thickness is 5 to 10 kilometers, so less thick. After crust, we come to lithosphere, which is the crust plus a small portion of the uppermost mantle. So simple, lithosphere. Then we come to a very important part of the Earth interior, which is the asthenosphere, which is highly viscous, plastic-like, ductically forming region of the upper mantle of the Earth, and it is over the asthenosphere the whole plates, or these oceanic and the continental crust, move. These different plates, the oceanic plates and the continental plates, they move over this asthenosphere. They float over this asthenosphere. So very important layer to remember, the asthenosphere. And also the second point which we need to remember for the plate tectonics. The first one, oceanic crusts are more denser, and second, the asthenosphere. Now coming to the mantle, we divide into two parts, the upper mantle and the lower mantle. Now obviously density of rocks will increase. So with this, the speed of seismic waves are the earthquake waves using which we analyze, actually we understand the earth structure. We don't have any other way. So this is the best way to analyze or to understand the earth interior, which is the speed of seismic waves. Core, we have upper core and the inner core. Upper core we have seen it is in the liquid form, and inner core we know it is in the solid form. Now we should be questioning why we know and how we know it is liquid. We have not been more than 30 kilometers inside the earth interior by digging the earth. So how we know below 2900 kilometer what is there? This question we will answer later. Now there are certain layers of discontinuities in the earth structure, interior of the earth. The first one is the Mohorovic discontinuity, which is between the oceanic crust and mantle. Then we have the Conrad discontinuity, which is between the oceanic and the continental crust. Then we have Rapiti discontinuity, which is between the mantle, the upper mantle and the lower mantle. Then we have Gutenberg discontinuity, which is between mantle and core. Then we have Lehman discontinuity between the outer core and inner core. So this is something actually which is difficult to remember, and there is no logical connection to this. So again, we will use our the power of memory. So, starting with the Mohorovic discontinuity. Mohorovic discontinuity, it is between the oceanic crust and mantle. Now we need picture for each thing. That is how we have seen throughout the course that pictures are our best friend. So using pictures we remember things. So between the oceanic crust and mantle, let us define an image for each. Oceanic crust is very simple. Oceanic crust is ocean. Ocean is a picture for oceanic crust. Then we have mantle. So from mantle we get a word mentor. Mental becomes mentor, which means a teacher. So oceanic crust and mantle, which is the ocean and the mentor. And now we have to connect it to Mohorovic. Again, Mohorovic, as such, we don't have any image. So we have to take an image out of this. From Mohorovic, we get Mohan. Mohan is a name of a person, Mohan. Okay, and if you have a friend by the name of Mohan, you can take his image. Or if you don't have any picture of Mohan, it is the Mohan Babu, who is a very famous actor in South India. So now we will club all these three images: the Mohan Babu and the mentor of Mohan Babu or the teacher of Mohan Babu, and they are taking instructions on seashore or ocean. So ocean plus mental is Mohan. So Mohan taking instructions on the seashore. Okay, on the seashore or on ocean with his mentor. So the discontinuity between the oceanic crust and the mantle, it is the Mohorovic discontinuity, or Mohorovic is Mohan. Coming to the second discontinuity, which is the Conrad discontinuity. Discontinuity is between. Discontinuity is nothing. It is the difference in the speeds and the characteristics of seismic waves as these waves pass through different layers of the earth interior. So Conrad discontinuity, it is between the oceanic and the continental crust. Now these pictures are simple. Oceanic crust, we already have a picture of ocean. Continental crust, also we have a picture like continent, our the surface where we live. So Conrad, we take a picture out of it. Conrad, like which rat? Rat matlab chooha. Which rat? Conrad. So the place where the ocean and the continent meets, it is a beach, a sea beach. So you can see this picture. This is a sea beach, and this rat is enjoying water sports on the sea beach. So you are asking which rat? Okay, Conrad. Conrad is enjoying on the sea beach. Sea beach is a place where ocean and the continent meets. So Conrad discontinuity is between the oceanic and the continental crust. Coming to the third discontinuity, which is the Rapiti discontinuity, which is between upper and lower mantle. So mantle, we already have a picture of a teacher or a mentor. So suppose she is your mentor. You may be so lucky to get such a mentor. So this is the mentor, and one day she came to the class with unusual dress. So she was wearing, this is the upper portion of the mentor, and this is the lower portion of the mentor. And she was wearing different dresses on the upper and the lower mantle. Why? You asked, like, why, teacher, you are wearing such a dress? Then she said she wants to go to a rap singing concert. So rap becomes rapiti. From rapiti discontinuity, or rapiti becomes rap. Okay, rap like how people rap. Honey Singh raps. So rap singer dress. So rapiti we are linking with the upper and the lower mantle, or the upper and the lower portion of your mentor or teacher. Then coming to the fourth discontinuity, which is the Gutenberg discontinuity. From Gutenberg, we got burger. Mental, we already have a picture of mentor. Now core become course, like course what we do. Now you went for a course to make a burger. So she is your mentor, and what she is teaching you to make burger. She is giving you a course on making a burger. So the discontinuity between the core and the mantle, it is Gutenberg, or from Berg we get burger. So Gutenberg discontinuity. Coming to the last discontinuity, which is the Lehman discontinuity, and which is between outer and inner core. Lehman, we have a very good picture, the picture of Darren Lemon. If you know something about cricket, the cricket players, he was a very famous player of Australian cricket team and also later coached the Australian cricket team. So Darren Lemon is going to be pitcher. So core, we have a picture of course. So you went to Darren Lemon for a course on cricket and he taught you in and out of cricket because he was himself was an expert of cricket. So in and out of the cricket. So inner core and outer core, the discontinuity is the Lehman discontinuity or Darren Lemon for us. Just close your eyes now. We'll revise it. Okay. The first, if I ask you the difference between or the discontinuity between the oceanic crust and mantle. So oceanic crust and mantle, ocean and your teacher, okay, who is taking the instruction, it is the Mohan Babu or Mohodevic discontinuity. The second discontinuity, if we see the place where the discontinuity between the oceanic crust and the continental crust, it is the rat, if you can see the corn rat, okay, corn rat discontinuity. Then third one, it is your mentor, okay, who came wearing as unusual ways. So upper mental and lower mentor, mental. And why she was wearing such? Because she wanted to go for an rap singing concert, rap singing concert. So rapidity discontinuities between the upper and the lower mantle. Then we have Gutenberg discontinuity or burger, which is between the mantle and core. And then we have Darren Lemon, the Lemon discontinuity, who taught you in and out, who gave you a course to learn the in and out of the core or of cricket. So core, in and inner core and outer core, the discontinuity is known as the Lehman discontinuity. Now we come to the next question, what we started, what we like in the agenda we discussed, why Earth has such layers, what it has today. Okay, so the first thing which you should note out of this is because of densities, because of different densities of layer. So this is the main basic reason of the different layers of Earth. Now to understand this, we will go back to the time when the Earth even didn't exist, and that time we have only hydrogen and helium, the only two gases which were present in the universe that time. They used to condense and form stars, we all know that. Then stars, using nuclear fusion, they generate energy like our sun produces with the nuclear fusion. All stars produce or generate their electricity or generate their the energy using nuclear fusion, not the electricity. Then stars die. Okay. Then what they do is they split heavier metals or heavier elements out in the universe, and one of them was iron that time. Okay, the one of these heavier elements was the iron that time. Now what will happen? There will be some fresh hydrogen and helium which will again form new stars, while the heavier elements, the other heavier elements which were splitted by the dying star, they collide with the dust and the debris to form the foundation of the different planets, the different asteroids, the meteoroids, whatever things we see in the universe now. So next is heavier metals, they collide with dust and debris to form planets. And different other things like asteroids, meteoroids, everything. Okay. Now we know when as we go near to the sun, we'll have more temperature. So we were having the high temperature in inner solar system that time. Now, what will be the result of this high temperature is the light and the volatile will further condense. Light and volatile elements will further condense. And this is probably the reason if we see our solar system, the innermost four planets like Mercury we have, then we have Venus, then we have Earth, then we have Mars, they are in solid state. Inner four planets are solid, while the outer one are still in gaseous form. We know that. Now, as Earth now start growing bigger, the different radioactive forces and the gravity started melting that mixture, okay, which was formed by the heavier the metals and the dust and the debris, and that was a time when actually different layers started forming as per their density. So, as Earth started growing bigger, the different forces like the radioactive forces, this is when Earth grew. Radioactive forces and gravity. They started organizing the different things, and that is how now what will happen is the heavier elements like iron and nickel went down, okay, to the deepest portions, and the lighter metals elements like aluminium and silicon, they remained near the surface of the earth, near the surface, near the surface. Okay, so this is how we have the different layers, starting from like we have a nebula star which then died, then splitted the different heavier metals into the universe, and then we have other things, and then we have this formation of earth density because of the densest metal which will go to the innermost part of the earth, and the lighter elements will remain near the surface. So we see like inner core and outer core, they are made of iron and nickel, while the uppermost portions of the layers, they are made up particularly of silicon, aluminium, magnesium, and other things. We'll see this composition, like certain elements, the overall composition which metal is in the highest. There was one question also in UPSC which was asked long back, I think some 10-15 years before, like core is made up of which prominent metal, so it is the iron. So questions which have been asked from these topics, they are very basic in nature, and as I have told, hardly 4 or 5 questions asked in this whole topic in last 20-25 years if we see the papers. Now comes a very important part, that how we know about the earth interior. And the first thing what we need to understand are the seismic waves. Or we can also call as the earthquake waves. EQ waves or earthquake waves. Broadly, there are 2 types. One we call as the surface waves, and second the body waves. Surface waves we call as the L waves, and body waves we call as the P and S waves. Now, as the name suggests, surface waves they travel on the surface of Earth. And the body waves they passes through the body of Earth. Okay, so two types of seismic waves. First are the surface waves, and second are the body waves. The L waves and P and S waves. So surface waves. Now suppose this is the Earth. This is the point where earthquake happened. So the surface will travel on the surface, while the body waves now will pass through the body of the Earth. So it can be understood that the surface waves are the ones which causes destruction which happened after earthquake. Okay, now we'll talk about the two types of body waves, the P waves and the S waves, actually, which leads to the further understanding of the interior of the Earth's structure. So we have two types of body waves, the P wave and the S wave. P waves, its name is P because these are the primary waves, and S wave, it is the secondary wave. The first difference is the P waves are the compressional waves. What it means is the particles they move parallel to the direction of motion, while the secondary waves are the transverse waves, which have a sort of up and down movement. Now the basic difference if we see between the primary and the secondary waves, or the P and S waves, is the way they move. Okay, so this is a compressional wave or a P wave, in which it moves, the particle will move in the direction parallel to the direction of the motion. Okay, and while the S waves will move like this. Okay, so this is the first difference. Now second difference is because of this way of motion of these waves, we have the P waves which are faster. So the P waves are faster, while the secondary waves or S waves are slower as you compare with P waves. The third difference is the P waves can travel through solids, liquids, and gases. Okay, while the secondary waves can travel only through solids. Only through solids. A very very important difference, and because we know, see, in solid you have the different molecules, they will present like this. So because of this motion, this can happen. Okay, this motion can happen if all molecules are together, but in liquid, if we see, they are far apart, so this motion is not possible in case of liquids, or even in the form of gases where the molecules are further apart. So this is a very important difference between the P waves and the S waves. P waves can travel in solid, liquids, and gases, while S waves can travel only through solids and not through liquid and gases. Please remember this point, because this point actually which revealed to the geographers, to the geology scientists, that we have where we have the different density of the rocks, where we have liquid inside the interior of the earth, because now we know if we have the S waves which cannot pass through the liquids. So if it is escaping a particular region, the S waves, definitely we are going to have liquid in that place. So this is P wave Okay, the faster wave. Then we have L waves, the up and down motion. Then we have surface wave, which is the addition of both P and S waves. So surface waves will go like this. Then we have S waves and P waves. Suppose this is the focus point and this is one of these observing station. The P wave will reach first. Okay, because it is faster. It is faster, and S wave will reach a bit later because it is a slower wave. Now the figure which you can see here, this is a seismograph. Seismograph, which will sense these seismic waves, the P and S waves. So these are located around the different corners of the earth, and whenever an earthquake is found at a particular place in the earth, we can see here, like suppose this is a earthquake center, then we have different seismographs which are placed at different locations. So this is the type of wave actually which this seismograph will draw. Let us draw it. So this is how something a seismograph will sense the waves. The first one will be the P waves because these are the faster waves. We know that. And then second, these will be the secondary waves. Now suppose there are two stations. There is station 1 which got the difference between these P and S waves as 2 minutes. Then we have station number 2 which this is the P wave and this is the S wave, and the time difference between these two waves is 1 minute. Okay. So now what we can deduce is the station 2 is first thing is nearer to station 2 is nearer than station 1 because the time difference is less. Now there is something known as the ESRT, which is ESRT, which is Earth Science Reference Table. Now what we saw in the last part, this is the difference between this is a one station seismograph station, and there is a difference of 2 minutes between the P waves and S waves, and using this time difference, we can find the location of that earthquake. Now this 2 minute difference we will try to put in this. So where exactly this will come? Suppose if it comes here, this is 2 minutes for example. So location or the epicenter of the earthquake is approximately this much from the epicenter, from the distance of epicenter from the seismic station. So this is the purpose of ESRT or the Earth Science Reference Table. Now S waves, these are transverse waves, slow moving and travel only through solids. P waves, longitudinal, fast moving and travel through liquids and solids. Now we will see how these waves helped us understanding the different parts or different layers of the earth. Suppose now this is the epicenter, and from this epicenter now we will have P waves and the S waves. Okay, so you can see this S wave is in black arrow and this P wave is in yellow arrow. We will see now these black arrows are not able to pass. So this is the epicenters and these all are the observing centers. So different observing centers are there all around the earth. Okay, so first if we talk about the S waves, these S waves are not able to pass this particular portion, the outer core. So this whole portion we call as the shadow zone. S wave shadow zone. So from this we can anticipate now there has to be some liquid material or liquid layer through which S waves are not able to pass. And when P waves are passed through the different densities, it ends up at some strange place. Okay, for example, it started from here, so you expect it to reach at this particular point, but they reach at this particular point. So they end up in different strange places because of the different speeds. Okay, this we all know. The basic property of electromagnetic waves, that they will have different velocity in different density of layers. Okay, this is the basic thing what we know. And another thing which we know is refraction. Okay, the very basic concept, the refraction, and how the speed of the light or speed of different waves, they differs in different layers or in different density of layers. So waves change their speed from one type of element to another, which are having their different densities, and bending because of again change in speed. So there are two things. One is the change in speed of these waves, and second is the bending or change in direction of these waves. Change in speed and changing direction. So that is how we came to know. Now, analyzing these different waves using different complex mathematical equations and other things, these whole the model inside the Earth became clear. Okay, using the properties of these P and S waves. Now we can talk something about Richter scale. Okay, Richter scale is, we know, use this particular scale to see the magnitude of the earthquake. The first thing is the Charles F. Richter was the person who discovered this particular Richter scale in 1935. The very important thing to understand is it is a logarithmic table. So what it means is one whole number increase will lead to 10 times bigger magnitude, and which will further lead to 31 times increase in release of energy. So one whole number increase, suppose from Richter scale 7 it increased to 6 to it increased to 7. So it will mean the magnitude is increased 10 times, okay, and energy is increased 31 times. So this is the Richter scale. And this is how actually it is calculated. The difference between S minus P, it is put here, then with change in the distance we have the change in the magnitude and then the amplitude. So this is a typical example of Richter scale. Okay, so now next class we will start with plate tectonics. We'll start plate tectonics part, then we'll move to the geological history of India, and then we move to the Himalayas, the northern Himalayas, the first geographical important feature of India. Then we'll move to the northern plains and the peninsular plateau, the islands of India, the coastal plains of India. After finishing these things, we'll move to the monsoon, the climatic conditions of India, which will then study the soil, the different soils in India, then the natural vegetation and agriculture. Okay, so these all topics will cover with the Indian physical geography. Also will cover the mnemonics with each lecture, so that conceptual and the mnemonics will finish at a single place. So certain mnemonics we left during the first phase, so those mnemonics we are going to complete in this lecture series, and it will not take much time. Some 2 or 3 days are going to be more than sufficient for Indian physical geography. But as I have told, you need to have atlas with you, you need to have geography through maps book with you, and you need to be very vigilant when you are studying the newspaper, when you are watching the news on Raj Sabha and the Lok Sabha TV, and obviously not India TV and the ABV news. Raj Sabha TV and Lok Sabha TV are very important for UPSC aspirant. Many things, many discussions what happened there, and they show the real news. They go into the depth of the news and not like the sensational news like the other commercial TV news channels. So we'll end this lecture here. We'll start next lecture with the plate tectonics and the geological history of India. Thanks for tuning in.